Welcome back. In this clip, we'll talk about the nParticle collision effects. Let's go inside the nParticles menu and create the nParticle emitter. So under the create emitter, we'll go inside the option box and use the emitter type as the Omni. Hit the option create. Now let's reposition this emitter and play the timeline. You can notice that these particles are now under the impact of the gravity, and let's do one thing. Let's make this particle collide with the ground plane. So select the particles and go inside the nucleus node and use this option use plane so that we can enable this ground plane. And now if you play the timeline, you can notice these particles are comfortably colliding with the ground plane. Let's change the particle render type from point to the sphere for better visualizations. Let's take a closer look and we can see the moment we play the timeline, we can notice these particles are actually colliding with the ground plane, but these particles are not colliding with each other, and they are still intersecting and interfering. So what if I want to create an effect in which I want to show the particle-to-particle collisions or particle self-collisions? Well, that can be possible if we go inside the collision section and use this option self-collide. The moment we create this, you can notice now particles are comfortably showing the particle-to-particles collisions, or they are actually colliding with each other with no more intersections and no more interference. Alright, but there are some other three important attributes which are required to be considered to study the overall collisions, and these important attributes are the bounce, friction, and stickiness. Let's talk about the bounce first. Bounce is the attribute of the nParticles which creates an effect of deflection and a rebound effect the moment the particle establishes its collision within itself or with the other nucleus objects. It simply means that once the particle collides within the particles or with the other nucleus objects, particle will move in the direction opposite to the direction of its impact or its collision. Let's do one thing. Let's increase the values of the bounce and take down the necessary changes. And now you can see once these particles are colliding, these particles are actually moving in the opposite direction of its collisions, and these particles are also carrying their own force and their own speed. So if we have higher values of the bounce, the particles will move with more speed and with more velocities in the opposite direction of its collisions. Alright, now let's do one thing. Let's roll this back to the 0 and now talk about the another important parameter, that is the friction. Well, friction is a kind of a force which acts as resistance to the overall movement or motion of the particles during the collisions, and it will significantly dip down the speed of the particles. Let's do one thing. Let's increase the value of the friction and take down the necessary changes. And the moment they collide, you can notice the particles are no more able to rebound, and their velocities have also decreased. Alright, so this is just because of the frictions. So the sudden dip down in the speed is because of the values of the frictions. Alright, now let's talk about the another important attribute, that is the stickiness. If I increase the time slider to a value of 2, you can notice the particles will try to stick with each other the moment they collide. And this attribute is quite different from the friction, because stickiness will actually affects the particle in a way like once the collision is established, particle will just try to stick to the point. But in case of the friction, particles still can collide, or particles still can move slowly or with some reduced values of the velocities. But in case of the stickiness, this parameter will just try to make the particle stick to a point. Alright, so that was all about the particle-to-particle collisions. What if we want to make the particle collide with the other nucleus objects? Let's do one thing. Let's create a simple polysphere and resize this and reposition this and play the timeline. And you can notice that these particles are simply ignoring the sphere by simply interfering with the sphere. So what if we want to create an effect in which particle can comfortably collide with the sphere? So let's do one thing. Let's select the sphere and go inside the enclosed, use the option create passive collider, and make sure that we are working with the same nucleus solver. So here we have nucleus 1 and here we also have nucleus 1. Hit the option make collide. The moment you hit the option make collide, you can see we have a new node, that is the nucleus rigid body. So this N rigid node will make the sphere eligible inside the nucleus dynamics, and now the particles can comfortably collide with this sphere. So if you play the timeline, you can notice the particles are now comfortably colliding with the sphere. And if you select the sphere, you can also notice that the sphere is now provided with the same attribute, that is a bounce, friction, and stickiness. Alright. So right now these particles are using the attribute stickiness, and because of this you can see the behavior of the particles, and they are completely sticking with each other. Now let's do one thing. Let's get rid of the stickiness and use the attributes friction. And if you play the timeline, you will notice once the particles start colliding with the sphere, they will continue to slide but with lower values of the speed. And this is how the friction affects the overall speed of the particles during the time of the collisions. Alright. Now let's do one thing. Let's get rid of the friction and increase the bounce. Let me also increase the bounce of the sphere. And now if I play the timeline, you can see once the particle establish its collisions, they are simply moving in the direction opposite to the direction of the impact or the collisions, and they are also supporting the deflections and the rebound effect. This is actually a kind of a deflection effect once the particle collide with the geometry, and when the particle moves in the opposite direction, this is basically we call as a bounce effect. Alright, so that's all for this clip. Now let's take a pause and end this clip over here. Now in the next clip I'll talk about the fundamentals of the collision layer. So let's get started with that one.